Bright Tuty. Every student matters.
Law of conservation of energy states. Law of conservation of energy states that energy can neither be created nor be destroyed. We cannot create energy, right? Nor it can be destroyed. We can only convert one form of energy into another. So one form of energy can be converted into another form, and during this conversion the total energy of the system remains constant, because when energy is neither created nor destroyed, so no new energy can be produced and no old energy can be wasted, right? It can't become zero. So that is why we basically see that law of conservation of energy holds good in each and every type of conversions. I repeat, law of conservation of energy states that energy can neither be created nor be destroyed. It can only be converted from one form into another, and during this conversion the total energy remains fixed, remains constant, remains the same. Got it? So this is law of conservation of energy. We'll try to prove this law of conservation of energy by doing a simple activity. What we will do is, we'll take an object, right, of mass anything like 20 kilogram. It is dropped from a height of 40 meters. Now let us see, when we allow this object to fall from this height of, I think I've said 40, it is 4 meters. Now let this be the ground level. So when this particular object is kept at this particular height, it gets some potential energy. Now we can easily calculate the value of potential energy. How? We know that potential energy is equal to m into g into h. The mass we have taken to be 20. Let us take g to be 10 for easy calculation, and the height is 4. This comes out to be 800 joules. So we can say that at this point in time the potential energy in the object at a height of 4 meters is 800 joules. Now at this particular point in time, at this position, when this object is kept at this particular height, there is no velocity or motion in this object. So we can say that the kinetic energy in this body is 0 joules. Now when I take the sum total, the total energy in this body, it comes out to be 800 joules plus 0 joules, that once again comes out to be 800 joules, right? So there is this potential energy in this body kept at a height of 4 meters. Now if I allow this body to fall down, right, the way it will fall down, it will lead to the decrease in its height. Let us take different cases. Let it be 3 meters height, 2 meter, 1 meter and 0 meter. That means the moment it strikes the ground, right? Now when I say that object is at a height of 3 meters, what I'll do is, I'll once again calculate its potential energy, same formula mgh, but now putting the value of h to be 3 rather than 4, and now I'll get the value to be 600 joules, right? Now the potential energy is decreased from 800 to 600 joules. Where has that 200 joule gone? That 200 joule has been converted into kinetic energy. Why? Because now the object is in motion, right? And because of its speed, it will gain some kinetic energy. And if I take the sum total of both, again I will get 800 joule. At a height of 2 meter, I'll again calculate the values. The value of potential energy will once again decrease. It will become 400 joule, and now because the ball has gained more speed, it will be having more kinetic energy in such a way that the total of both is again 800 joule. At a height of 1 meter, the potential energy will be 200 joule and the kinetic energy will be 600 joule, and the sum total will be again 800 joule. Now just the moment it will strike, the height of the ball will become 0, because of which the potential energy will be 0, and the speed of the ball or the object will be maximum. It will be 800 joules, and once again the total of kinetic and potential, that means the total energy possessed by this object, will be 800 joule. So now this particular experiment, this activity, this is said to be an activity which proves the law of conservation of energy. We can take it to be an object or to be a free falling elastic ball, right? And by this activity, how we can prove the law of conservation of energy? In this activity, we see two distinct things. First thing, we saw that the moment the ball is thrown down and as its height goes on decreasing, the potential energy which was initially maximum, right, it becomes 0 by the time it gets down to the ground, and the kinetic energy which was initially 0 becomes maximum. So this activity shows the interconversion of one form of energy into another, that in this case we see that the potential energy is getting converted into kinetic energy. This is the first point of law of conservation of energy, that energy can be converted from one form into another form, which in this case we saw that it is being converted from potential energy into kinetic energy. And the second most important aspect of law of conservation of energy is that during this conversion, at any point in time, if we relate, then the total energy remains fixed or constant, right? There is no loss of energy whatsoever during the conversion. So hence we can prove that law of conservation of energy holds good. Now this is very important from exam point of view. You are being asked that explain the law of conservation of energy with the help of an example of free falling object or free falling elastic ball, right? We'll assume some values and we have to show this table in order to prove it, and then we need to explain using this table that this activity shows the law of conservation of energy is proved. How? Because in this we see that the energy, potential energy, is getting converted into kinetic, and during this conversion the total energy has been fixed at any point taken into consideration. Got it? This is law of conservation of energy. Fine. One more important thing that comes to relate the conversion of energy is in the case of simple pendulum. Now what is a pendulum? The pendulum is just a ball which is just tied up to a thread and it has been fixed and it is allowed to fall or move freely, right? Now in this case please try to relate. First thing, now this actual normal position, the starting position of this ball or the pendulum is known as mean position. This is the mean position. Alright. Now when I just raise this ball to a particular height, let it be this height. Alright. So at this particular height, if I hold the ball, this position is known as extreme position. So mean position and extreme position. When I allow this ball, when I release this ball will oscillate into this motion, and it is not going to stop at the mean position. Because of the momentum gained, it will go further and it will reach a particular height, let it be this height. Now this is the maximum height that it achieves, right? From where it will again, initially it was going like this, but achieving this height, it will again turn back. This height on this side is also known as extreme position. So we have got two positions. One is mean position in the middle and another is extreme positions at the two ends, right? Now as compared to the mean and extreme, when we relate them, at the mean position the height of this particular pendulum was 0. Therefore we can say that the potential energy was 0. When we just took and carried this ball to a particular height, to this extreme position, now the height is the maximum that we have taken, so it has got potential energy at this extreme position because of its height. Now when I allow the ball to be released, right, so in between this extreme position, please try to relate, in between this extreme position and the mean position, the ball has some height also, as well as the ball is in motion also. So I can say that here the ball has got mechanical energy, means it has got potential also and it has got kinetic energy also, right? The moment it reaches the mean position, now the height becomes 0. That means there is no potential energy in the ball. Which type of energy will it have? It will have kinetic energy only. So it will have kinetic energy at the mean position. The fraction of second later, when it again goes up, now once again it is gaining some height, more height. So again it has got mechanical energy, that means it has got potential as well as kinetic energy, right? Till what point? Till the extreme position. Now at this extreme position, the ball will just stop for a fraction of second, and at that fraction of second, because the ball has stopped, now the kinetic energy will be 0, and because of the extreme height it could have possibly achieved, the potential energy will be maximum. So please try to relate the whole scenario. The total energy conversion taking place in the simple pendulum is at the extreme position. Let us relate. At the extreme position, it has got potential energy. From extreme to mean, it has got both potential and kinetic, that is the mechanical energy. At the mean position, it has got only kinetic energy. Again from mean position to extreme position, it has got mechanical, that means potential and kinetic both, and at extreme it has got once again only potential. So at extreme positions only potential energy, at mean position only kinetic energy, and in between when it oscillates then it has got both of them, right? So this is also a very important question that is asked normally, that we need to explain the energy conversion in the case of simple pendulum. So we have to draw this figure also and we have to explain properly, because probably it will be minimum 2 marker and normally a 3 marker question. Clear? Fine. So this is all about law of conservation of energy. I repeat, what is law of conservation of energy? It states that energy can neither be created nor be destroyed. It can only be converted from one form into another, and during this conversion the total energy remains constant. We have seen the case of a dam. What type of energy is getting converted into it? We have taken the case of a free falling elastic ball or a particular object falling. We have taken the example of simple pendulum, and we have taken a few examples from our day-to-day life, right? There are more examples, numerous examples which we can observe and we can relate in our normal day-to-day life, where we see energy is getting converted from one form to another. Fine.